Okay, you can start.
Thank you very much, and thanks also for reading out this very long title, so I don't have to do it. Welcome, my name is Kasimir-Environmental. I'm from the Technical University of Munich, and I'm going to present my PhD thesis in 3 minutes now. So about the background and the challenges we are currently facing in the buildings and construction industry. So around 13% of the global GDP is related to buildings and constructions. At the same time, 90% of all our time people spend indoors, so the social aspect, not just the economical aspects, but the social aspects are getting more important, especially not just in regards to well-being and comfort, but also to health, so long-term aspects. But my main focus is on the environmental criteria, especially on the climate change related CO2 emissions. 40% of the global CO2 emissions are related to buildings and constructions, while 11% globally speaking are directly connected to material manufacturing, which is still underestimated and in practice not that much considered yet. And additionally, we had already a talk about material passports and circular economies. Our industry is responsible for 40% of the waste generation and around 50% of our resource demand. So generally, we are facing a lot of different criteria we should consider already in early design phases when we're able to optimize our building designs, and we should consider them all together and not individually. So the problem I'm facing in my thesis is that in early design stages, BIM has still a lot of vague information. So usually we are still working with benchmarks. On the other side, the detailed design stages have a lot of information, but we can't optimize it anymore. So in my proposed methodology, I want to bridge that gap by semantic model healing for life cycle assessment, so calculating embodied carbon. For this, I implemented a knowledge database, and my input is the early BIM models. And the main part I am facing in my proposed methodology is matching this knowledge database with the formalized information from detailed design stages using natural language processing, NLP, to the BIM model, and by that getting reliable results of my LCA calculations and the holistic calculation of the embodied emissions. The framework offers also additional calculations in future, such as circular economy indices or costs or operational energies. And finally, the framework finishes with visualization and showing a variance, and in the last stage, selecting the variance in an early design stages and communicating back these changes to the BIM modeling. That's my thesis in 3.